Hi everyone. Can you hear me? Can somebody tell me in the chat if they can hear me? I think it's good. All the matters are good. So I hope you are doing fine. We are here to talk tonight about Starship because there's a lot to talk about. Elon Musk tweeted a lot about the recent improvements, and of course there are the three videos by Everyday Astronaut that teach us a lot about the Starship development so far. So I think it's good. I will go on with it. Here we are, closer than ever to the Orbital Starship test launch. But that's not just an orbital test launch of yet another rocket, no matter how tall it looks, how powerful its motors are, or how cool we think it is. Make no mistake, this flight will be written into history books. And if you are watching this right now, I think you probably know what I'm talking about. That's because Starship is so much more than a rocket. Its goal is to lower the cost to Earth's orbit so much that a new industrial revolution could start, and of course, make life multiplanetary, with a human settlement on Mars. That's my opinion, and clearly, that's the message Elon Musk is trying to convey when he tweets the now famous black and white picture of SN20 stacking on top of Booster 4. Here you have it. Many people have commented on this picture, but I will just recommend to you the article by Eric Berger. I think he summed it all up much better than I could. That's this article. I will get back to this later. Although it might seem so obvious for us space enthusiasts that have been following the development and often explosions of the early prototypes, not everyone is seeing Starship tests with a friendly eye. Let's start with NASA. The administration should be quite excited to see progress happening on its selected human landing system for Artemis, right? Have you seen their reaction about it? Yes, me neither. That's because they did not even tweet about it. I find it hard to understand that such a milestone in a critical component for USA's program to return humans to the surface of the moon could not provoke any reaction amongst all the agency's communicants. Surely someone at a high position is not very happy about Starship being selected for HLS. On the contrary, we've heard from Blue Origin, although this was not really a praise for the achievement, rather another loser's rant that looked a bit childish if you ask me. That's what comes with innovation. No matter how hard the technological side might be or how rewarding the benefits could be, there will always be some people actively benefiting from the old system. And they are trying to hold you back. And I think Elon Musk and SpaceX approach so far is the right one. A radical openness about all progress, setbacks, explosions, and success. That's the only way to confront the people trying to hold you back. Hit them with facts. A big old reality check to expose everyone. Let's see who is right in the end. So let's hop on this train and try to check all we know so far about the Starship system on the orbital launch test. Don't hesitate to share your comments, opinions, or questions in the chat. I'll try to address them at the best of my abilities. And of course, you can always correct me if I'm wrong or if I'm saying something stupid. So let's get back to the national team pamphlet. They published rather interesting infographics. They say that's an immense complexity and a heightened risk. They are talking about the Starship and on top of the Super Heavy. They're saying the whole stack will need 16 Starship and Super Heavy launches to launch the HLS and refill it before launching it, sending it to the moon. But first, that's exactly why NASA chose SpaceX. Of course, they were cheaper, but the complexity is right in low Earth orbit, where it is easy to address the problems, not around the moon like the national team did it. And NASA said that in the report about the choice of SpaceX, and they say it was a strong point for SpaceX to be able to assemble or refill their Starship in low Earth orbit. But of course, uh, Elon Musk answered because he couldn't let it pass. He said, however, even if it were 16 flights with docking, this is not a problem. SpaceX did more than 16 orbital flights in the first half of 2021 alone and has docked with station, the International Space Station, which is much harder than docking with your own ship, over 20 times. So this is quite routine for SpaceX. So of course, Blue Origin couldn't even reach orbit, so this might seem complicated for them. But he also ranted a bit about Jeff Bezos. He said if lobbying and lawyers could get you to orbit, Bezos would be on Pluto right now. And that's of course, because Bezos couldn't let the contract for the HLS go to SpaceX, and he was trying to win it by waiving $2 billion, and now he's trying to sue NASA. He's threatening to sue NASA if they don't accept the national team's proposal. The people working at Blue Origin are mortified by this. There are tweets by Eric Berger that say his contacts at Blue Origin, they do not endorse this kind of behavior. Of course, the top management, Bezos, and everybody, the top ranking managers at Blue Origin, they want to fight in the courts to win the HLS contract, but that's too late. They should have done it when it was time. So we have a lot to talk about, and we also have the that thanks to Everyday Astronaut, and if you did not watch his three videos, his three last video here, encourage all of you to watch them. It could be long. The first two are about 1 hour each, but they're really interesting. They are talking very technical points, and the last one is more about what it's like to be around the Starbase, and with all the people working around. That's really, if you have only one to watch, only 20 minutes to watch the last one, the third one. It's really interesting, if you ask me. There is an army of workers working day and night, and Elon Musk says, if we operate with the extreme urgencies, then we have a chance of making life multiplanetary. That's very interesting, because Musk thinks we only have a small window to reach Mars, or else we might only stay in low Earth orbit. He said in '69 the USA were able to reach the moon, to land people on the moon. Then there was a space shuttle which only reached low Earth orbit, and then for almost a decade the USA could not reach space anymore, and that was a really strong trend towards the decline, and he wants to fight it with all its capacity. Space is not a given. In Europe, we do not have any mean to send people in orbit. We only rely on Russians or the Americans for that, and maybe someday the USA will stop sending people to space. That's not a science fiction. That's not only in the movies. It could happen, and I think Musk is doing quite a good job at working against this trend. And he's not alone. He has a lot of people, the people that are working for him. That's what we see in this. That is really striking in the last video from Everyday Astronaut, that the people working with him are really motivated. They like working with him. They like doing what they are doing. Just a quick example, when he first arrives at the launch site, there's a man that greets him and hugs him, and he says, "We're gonna make it." Just show it to you. That's of course, yeah, yeah.
Hey, how's it going?
Let me give it to you something.
Okay.
This one. This for you.
Okay. Thank you.
All right.
Thanks.
We're gonna make it.
All right.
We're gonna make it. And that's not just this guy. There's a. You just have to watch the approval ratings. Again, Eric Berger tweeted about this a few weeks ago. In the on Glassdoor, the website Glassdoor, the US rocket companies are ranked like every other companies, and Relativity Space has a 95% approval for the CEO. SpaceX 92%. That's huge for a really small, really big company. Usually only the small companies have a huge approval rating. Rocket Lab is a bit lower at 81, but Blue Origin is only at 18% approval for its CEO. That's quite low on the opposite. So how is Musk dealing with all these challenges? He has quite a unique method. He's an engineer, and he chose. When there are problems, he has his own method that he learned the hard way, of course. It's a 5-step process. Step 1 is make the requirement less dumb. This means you have to think about the people that will have to read your requirement. If you say this has to withstand 200 tons of thrust, this beam has to withstand that force, you have to specify a little more in what conditions this force will be applied, etc., etc. And also the requirements must come with the name of the person that made it, not the department, because you can then ask the person what the requirement was all about in the end. That's really important, because Musk personally experienced requirements that were dragged along for years with Tesla, that had no meaning at all in the end, that were just bothering the supply chain and the construction chain. And you have to be able to ask the person that made the requirement. And then step 2, you have to try very hard to delete delete parts or processes, because if you want to achieve not only orbit, but the Starship should be able to come back and get back to orbit really fast, and that's a few steps higher requirements than usual rockets. And if you want to do that, you have to optimize. And to optimize, you have to try very hard to delete the most parts possible. And the process is also. And Musk says, if you are not putting things back in that you have deleted but wrongly, then you are not deleting enough. You should be deleting too much and then putting the things back in, because in the end they were really needed. Once you have made the second step, the third step is to simplify or optimize. Once you have your part, and you know your part is mandatory, you have to have it, you can then try to optimize it. He said the most common error of engineers is to try to optimize things that should not exist in the first place. That's because at school you have to answer the question that the professor asked, but you cannot tell the professor he's wrong. You have to answer the question. So when your boss asks you to optimize some part, you will do the exercise as if he was your professor, but in the end, maybe the part should have been deleted beforehand. So once you are sure that your part is mandatory, then you can optimize it. And once it's done, the fourth step is to accelerate the cycle time. You want to build faster. And once this is achieved, then you can automate. Make a machine that will build the part for you, or assemble the part. That's the last step. And he said in the interview with Everyday Astronaut that in the past he was very often doing all the tasks in the wrong order, and that's not the right thing to do, because you're losing time and money. You have to follow these rules eventually. So this is his philosophy, and of course he is he has a commitment to milestones. Right now he's focused on the orbital test, and it shows everything that is not related to this orbital test. They are not even working on it. For instance, the door, the payload door on the Starship, they had a few design iterations, and they have completely stopped working on that, because that's not necessary. The first 10 starships that will fly to orbit and maybe come back will not need to have a payload bay, because they will not have any payload of any sort. So that's how he works, and he also he also thinks it's very important to have as a culture, a farm culture, a culture that it's okay to fail. He says, of course, the exception would be Dragon. The Dragon spacecraft cannot fail, but every other ship can fail. And if it fails, you learn, because you want to push the limits, to push the envelope. He calls it. That's an aviation term. The envelope, the flight envelope, is how far you can reach with your plane, how high you can fly, how fast. That those maximums are the envelope. And in order for the Starship to work, to be rapidly reusable, you have to push the envelope, because with the today numbers, this will not be possible. So to push the envelope, sometimes you go too far, or you have to go too far to see what's wrong, what breaks, what burns, and then change something to then go farther. So even if it breaks, there is something to be learned, and that's why they have lots of explosions. There are always explosions in rocketry, but SpaceX has maybe a bit more. But on top of that, they are washing the dirty laundry in public. Everything is in public. So we watch the Raptors malfunction or explode. Watch Blue Origin with their BE-4. They have to deliver 2 BE-4s for the Vulcan first launch in a few months maybe, but they couldn't deliver anyone. They their plan is to deliver four BE4, two to deliver to ULA to mount on the rocket, and two to test in the to test in the flight conditions and to see if they fail. That's too few. That means if something fails during the test, they have to remove the BE4s that were installed on Vulcan and work on the problem and produce new motors, test them, and then mount them again. That's not that's not how SpaceX does the things. They try everything in flight, in test flight, and things explode, and that's okay because you know how it explodes and you know how to fix it. And the last very nice thing is Hayes. He says he can often be what he says one week can be untrue next week. That's not because he's wrong or lying. That's he might be wrong sometimes, but sometimes he just misunderstood things with his coworkers and then said some things that were untrue, and it's corrected. Or sometimes they just change plans because they are going so fast that they stacked the Starship on top of the Super Heavy faster than Tim Dodd released his video. It was faster for SpaceX to stack the Starship on the boosters than for a YouTuber to release the video. That says something, I think. So onto the technical points. We have what he calls the pad, which is the stage 0. He says stage 0 is not only the launch pad, the launch tower, the quick disconnect arm, but also the tank farm, all the lines, all the systems that are on the ground and necessary for the flight to happen. That's very important because if you optimize stage 0, that's all the more things you do not need on your rocket, and your rocket will be lighter. And therefore the stage 0 is very complex, very complicated to build, and in fact much complicated than a booster or a super heavy booster or a Starship. That's why they don't want to risk it in an explosion, and the flight plan will be avoiding the return to launch site. So we have the tower. In the end, they want to catch the booster with the tower, with what he calls chopstick arms that will be just under the grid fins when the booster lands, but it's not tested yet and it's not ready yet. So don't expect that for the first flight, and probably for the first flights, plural. We have the launch mount. So we have the sort of stool, the milking stool, if you keep the reference from the Saturn. But the rocket doesn't stand on the stand directly. You have to have a launch mount, which is very heavy piece of steel with 20 mount points, and they were working for a lot of days on that, and they had to try to fit it on the launch stand, and they were not sure if it fitted or not. So they had to work a bit because it was loose on some side. But now it's okay. It was adjusted, and everything is fine. So there is a very important part that is almost installed on the launch tower. This is the quick disconnect arm. They call it the QD, quick disconnect arm. This will serve as to bring fuel to the booster on the Super Heavy, the booster on the Starship, but also this will maintain the booster on the pad to protect it from winds, etc. And just before the launch, it will disconnect and move back to allow the Super Heavy and Starship to lift off. So this is a huge piece of steel with plumbings, electric wires, all of that will move to secure the booster on the launch pad. So we also have then we have the booster, the first stage. The booster will have the density of an empty beer can, because when it's empty, it's only a thin wall of steel, and it's just as an empty beer can, plus the motors on the bottom. But basically, this is very light. Although it's in stainless steel, it's really light. The dry mass should be just under 200 tons, which seems a lot, but given that it's 69 meters tall, it's not that much. We have the engine and engine mount, 2 ton each. You have to multiply that by 29. It's almost 60 tons. The fuel and oxidizer tanks, 80 tons each, 80 tons total. The answer stage and everything that's in it, that means the grid fins, the batteries, etc. That's 20 tons. You have to account for the propellant residuals. When the booster will land, it will not use the last drop of fuel to land. It will be suicidal because you have to have margins, and margins on something of this scale, it represents, as of today, about 20 tons. The Falcon 9 nowadays still lands with about a ton of unused fuel, and there is potential for optimization, because the engines are really optimized up to the very last percentage, but there are tons of, literally in a Falcon 9, a ton of fuel that goes to space, goes back, and then lands on a barge. That's a bit stupid, but you have to have this margin to be sure to be able to land. So probably there will be some work in the future to reduce it. Maybe not on the Falcon 9, but on the Starship, the booster, there are 20 tons. They are talking about 20 tons of residual propellant. That's a lot. So that's about between 160 and 200 tons for the dry mass, what they call dry mass. Dry mass would be not really completely dry, but the landing mass, depending on the final mass numbers. This is a work in progress, so the mass is really fluid. It could change in one way or another quite rapidly. What Musk says, he says the avionics is too heavy. He wants to work on the grid fins and the batteries, and but I will go through that in detail. The booster propellant mass is about 78 to 80% oxygen. That most of the mass is oxygen, not most of the volume is methane, but the mass is oxygen, which is a good thing because it's cheap and easy to make, easy to process. So that's a good choice to have a metal-ox mix in the booster. And now the grid fins, there are 4 grid fins, just as the Falcon 9, but the grid fins are electrically powered, not with hydraulics like on the Falcon 9. There are batteries, Tesla batteries, that are moving the Tesla motors to orient the grid fins in the wind. But the problem with the batteries, they are made for cars, for the Tesla cars. I think it's a Model 3, but I'm not sure. And a car needs to have power, sustainable power for a long time. But these grid fins, they need a lot of power, but for a very short time. So they are not optimized. What Musk says, they are energy optimized. There's a lot of total energy in the batteries, but they need a battery that is power optimized, something that can deliver a lot of power rather than a lot of total energy over a long period of time. This could reduce the battery the battery weight by a factor of 10. That's a huge gain that they can have on this side. The grid fins, they do not fold like on the Falcon 9 because they realized that it's not necessary. That's part of the 5-step process. You don't On the Falcon 9, maybe they went a bit too quick and they optimized the grid fins with titanium without realizing that they didn't need to fold them for launch, because if you are really streamlined, you are going right in the wind. It doesn't work. It doesn't have any effect at all. It only at higher incidence, it will deflect the air and then make your rocket turn. So they will keep their grid fins open, and therefore they will gain a lot of weight and complexity because they do not need to have the hinge and a motor to lift them up. But Musk said on Twitter that maybe the grid fins are not the show you. Yes, he said the grid fins, they clearly work, but do they maximize payload? Maybe not. Good chance that they're not. So he wants to look for something with much more drag to reduce terminal velocity in the way back, in the way down, to reduce landing propellant, and maybe with that they will have a better performance. So something like an air brake that could also steer the ship, because they need to steer the booster on the way back, of course. So the Falcon 9, it glides a little because the Falcon 9 didn't come back straight at the target. It comes a little off and steers to glide a little. It's not really gliding, but it helps to shave a little speed and reduce the speed while going down. And at the last moment, when the motor ignites, it comes back straight up to land. This will not be possible with the booster, the super heavy booster, because it's so big. There's a huge moment of inertia, and they cannot afford to swing it from one side to the other. So it will go straight down at a high speed and land quite directly without turning like the Falcon does. And the grid fins, maybe you have noticed, they are not at 90 degrees angles like on the Falcon 9. They are closer by pairs, with pairs, because they need more authority on the pitch. Pitch would be if you want to aim farther when you're going down, if you want to aim farther or closer, you need pitch to adjust that dimension. On the roll axis, if you want to roll like that, they do not need very much many authority. On the yaw axis, the yaw is this side. They do not need. They need more than the roll, but not that much. The really important part is the pitch axis. So they grouped the grid fins together to have more authority on that axis. And that's all about the grid fins. Those are the Raptors. That's the fun part. So how do the goal with the Raptors was to make the cost per ton of thrust under $1,000. The goal of Elon Musk and SpaceX was to reduce the cost per ton of thrust. That's a really interesting metric because usually you calculate you use the thrust to weight ratio to know if your motor is powerful enough. But what's really interesting is not the number of motors. He can add a little more if he wants. What's interesting, what Musk wants, is a cheap motor that does the job. It doesn't need maintenance because that would not be cheap anymore. And he wants to have a really low thrust cost per ton of thrust motor. So there are on the Booster 4 there are 29 engines, and maybe you saw the engines during the stacking. Some of them are another color. That's because they were not tested. So some of the motors are still not tested to this day. So they will need to test them before the launch. So watch the color of the bell, the inside of the bell, and if it's white, you will know that the launch is not scheduled for the next few days. They will need to remove the motors and test them before the real flight. That's on the booster, on the ship, as they call it, the Starship. There are three sea level Raptors, as we saw during the test, but also three vacuum optimized engines. The vacuum optimized are mostly they have a bigger nozzle to accommodate the low pressure, there's no air pressure in space, and to increase the efficiency, you need to have a bigger nozzle. And because it's so big, it's not the vacuum Raptors do not steer. They are not steerable. So during the separation, they will light all 6 engines, and then they will cut the sea level once they are close to reaching orbit. To reach low Earth orbit, they will need all 6, but after a refill, after the Starship is refilled to reach Mars or the Moon, they will preferentially use the vacuum optimized, because with the same amount of fuel, they will get more thrust, and then be able to have a better miles per gallon, if you want to reach farther destination. The sea level Raptors on Mars will still be used to land, of course, because they are better. They steer. They can gimbal to correct the orientation of the spacecraft during landing. They could not land with only the vacuum optimized Raptors. So the volume production of Raptors will be at the McGregor, Texas, but in California they will still be developing the new versions and producing the vacuum optimized Raptors. That's interesting because they still want to have two sites of production. Maybe in the future they will use only one plant to produce everything. There is a new version that's about to arrive. We are now on the Raptors version 1, but version 2 will reach 230 tons of thrust at sea level. That's I think it's 170 today with the version 1, because they increased the pressure in the chamber, but also they opened a little bit of the throat. how to explain that. The thrust chamber, if you have a high pressure in the chamber, you have a high efficiency. And if you manage to have this high pressure flow through a very narrow a very narrow throat, it will increase the speed of the exhaust and then increase the efficiency again. But in order to achieve the high pressure, they had to open a little bit the throat because that's a very tight area with very high pressure on hot gases. It could melt if it would have melted. So they had to open a little bit the throat. They lost a few seconds of ISP. ISP would be the miles per gallon. They lost a little bit on this side, but they gained so much more thrust that they thought it was worth it. So the second version will have an extra thrust and minus 2 or 3 seconds of ISP. He then talked a little bit about the HLS lander. He would want to land without the top thrusters. I don't know if you watched, but the HLS proposal by SpaceX had all the 6 Raptors on the bottom, but to land on the moon, the final phase of the landing, it used a little bit like the Super Draco thrusters, a ton of 24 thrusters on the top of the Starship, the lunar Starship, to land. That's because this way the flame of the thrusters would not disturb the lunar regolith, and if you aim a Raptor or any motor for that matter too close to the regolith, you dig your own grave. You dig a trench and then you land in it, and as Musk said, you dig your own grave and then you fall in it. And of course you do not want that. But he didn't reveal how he wanted to do that, but he says that maybe they could have a way to mitigate the problem, maybe but by deep throttling all 6 Raptors on the bottom to have a larger area and then maybe this could be enough to not lose the lunar dust, to not dig a hole in the lunar dust. But of course, if they want to go with that option, they will have to demonstrate to NASA that it's okay, that it's not a risk for the astronauts. We'll see what comes out of that. So what about the Raptors? Another really interesting point about the Raptor 2, it would be a massive simplification. On the outside, it will be visibly clearer than the Raptor 1. There are a lot of plumbings around the thrust chamber, and almost everything will go. This will be much simpler, says Elon Musk. And of course, this will help reduce the cost of production because Raptors will be cheap in the end, but right now they are really expensive. And what will make them cheap is simplifying the construction process. So and it will not stop at Raptor V2. Of course, they will go on with version 3 and 4 and 5 and etc. As they did with the Merlin engine. So once the booster has reached the end of its course, it will have to separate to launch the Starship that is on top of it. And to do that, they want to simplify the process from the Falcon 9, and instead of having a big pusher that sends the second stage away, they want to do that just as they do with the Starlink satellites. They want to fling the whole stack by turning the Raptors. At the end of their burn, they will move on the side and initiate a rotation and the rotation will fling the starship away because they will detach, decouple the two vessels, and it will fling the starship away from the booster. At least that's what they hope they will achieve. Of course, they could crash into each other. We don't know what will happen. That would be quite impressive if you ask me. I want to see that. I hope we can see something with the onboard cameras, because this will be very high up, and only the onboard cameras will be able to transmit something about that. So and a second optimization would be to not have any kind of thrusters, the RCS. The Starship had the cold gas thrusters to help it steer, but for the booster, they want to remove everything, because with the rotation initiated by the Raptors, it will start this rotation, and then when it's on the position to start the boost back burn, it will just start the engines. No need for RCS if you are already spinning, hopefully in the right direction. So they need some kind of control, of course, and they will, to do that, they will use an interesting system, what Elon calls ullage gas. So the booster propellant is in the tanks, and the tanks have to be under pressure to deliver the content, the methane and oxidizer. And to achieve this pressure on regular rockets, you use helium, but on Starship, to simplify things, because helium is really expensive, they want to use there will be some gas generator on the Raptors. Not every Raptors, but some Raptors will generate gas, pressurized gas, that will go back to the tanks and pressurize the tanks. So the tanks, on the bottom, there will be the liquid oxygen or liquid methane, but on top of that, there will be hot gases, hot combustion gases, that will be on the upper half of the tanks. And of course, as the rocket moves up and the tanks are emptying, there will be more and more and more hot gases in the tanks. So by the time the booster reaches its apogee, or at least the separation, there will be a lot of hot gas at 6 bar pressure in the huge tanks, much more gas that would ever be needed to steer any kind of vessel. So they want to use this gas that is already there, that is mandatory to fly, and they will use it to steer the ship, and in fact they will reach an efficiency that is close to that of the Dragon with its RCS. The RCS on Dragon has a pressure of 8.5 bars. 6 bar is not that far. So that's an interesting optimization. So the orbital test, the goal is to make it to orbit without blowing up. Musk doesn't talk about going back. Of course, it will go back, but the real goal is to make it to orbit without blowing up. Then, if the booster does its job, but something goes wrong with the Starship, it would still be a good thing. But if the Starship explodes, but not on the stand, on the launch stand, and therefore there are no damage on the stage 0, that will be a setback, but not that bad, because they could retrieve data, know what went bad, and not have to repair everything. So one thing to note on the orbital test would be to the liftoff. Because of the thrust to weight ratio, I've not calculated it, but it will be very fast on the beginning of the flight. It will really zoom out of the pad really quickly. That will be really interesting because a huge rocket like that, bigger than the Saturn V, this is the biggest rocket ever. That will be quite a fast rocket too. So that will be quite a sight to see. Um, and once the booster has reached its apogee, it will make a boost back burn because it will be too far. They want to go back to the launch site, but not quite on the launch site. They want to land something like 20 kilometers away from the launch site. So they will have to relight the engines, come back, and hopefully everything goes well, and it will try to, as if it was landing on the launch pad, but on water. And of course it will hit the water, hopefully at a low speed, and fall and probably think. But and the Starship will make three quarters, will make it to orbit, but a bit low, a bit too low to make a full orbit. And after three quarters of around the Earth, it will start to come back one way or another, even if it's a wreckage at this point, it will come back, and then the re-entry heating and everything will start. That's why we can talk about the thermal protection system, that it hold well during the low altitude flight. These are hexagonal tiles. If you want to watch, these are visible on the black and white photo. So most of the tiles are the same, all the same hexagonal tiles, but as you may see, there are a few exceptions. On the side, if you look at the right part of the flap, some tiles are square, some are squared with a semi-hexagonal border, and on the round edges, there are special rounded tiles that will protect the edges. So most of the tiles are the same. This is a huge improvement compared to the space shuttle, but there are some tiles that are quite different. They have to withstand quite a huge difference in temperature, because it would be room temperature before the launch. During the launch, it will be cryo temperature, and then when it's in orbit, the ullage pressure with hot gases will be very hot. The outside still will be very hot, and then when they come back, this will be blazing hot, like a meteor hot, and they will have to withstand all the stress, the temperature stress. So there is an attachment system with three rails, and the tiles are clipped on these rails, and they cannot be removed. To remove a tile, they have to drill a hole inside it and basically destroy it to remove and change it. Because there are a lot, to this day, there are still a lot of broken tiles they have to change before the flight, and there are still areas not covered with tiles. So this is really important to have an efficient system to attach the tile, because if the tiles are banging onto each other, this is ceramic, this is a plate, they will crack. So if they crack, the Starship is toasted and it cannot go back. So since it will most likely fail during re-entry, how to spot where it fails? One interesting option that must discussed discussed was to put a camera, just a regular camera, inside the tanks. And since the outside walls of the tanks are also the outside walls of the ship, uh, if there is a flame that if there is a tile that fails, and then some part of the steel that is really hot, it will start to glow before melting. So a camera could have quite a good idea to where is the point that failed, and from that working backwards to know what went wrong and what kind of improvements they could make. Of course, they will have a lot of thermal sensors, but maybe they will put some cameras inside the tanks. So the goal of the tiles and the flight profile is to minimize the peak heat. They don't want to have at any moment the heating that is above a certain threshold. That's not what is done with the Dragon. The Dragon comes back very steeply with a very high peak heating, because by coming down very steeply, it slows down quite fast, and therefore the total heat load is minimized. Because if it stayed too long in the heating of re-entry, the tiles would melt. The glue that the tiles are covered in would melt, and once the Dragon is under the parachute, a tile might get loose and fly into the parachute, and the tile, of course, would be very hot and dig a hole in the parachute, which would be very bad for for the landing. So the Starship, on the contrary, doesn't care. They just want to reduce the peak heating. So now onto the Starship in itself. The mass of SN20, they do not know the mass yet, because they change some things so regularly that they do not have a really precise notion of the weight. They will weigh it just before launch to be sure to know how much it is. And Musk said, hopefully it's not much more than 100-ton dry mass. There are, of course, a lot of improvements still in the works for the future versions. If you want to watch, I have here on the Everyday Astronauts video the future Novscon here. A future version of Novscon. If you watch on the back, that the old Novscons, they have 3 rows of plates, and this one only has 1. That's a simplification against the old ones, and they are much slicker, much nicer to look at. So that's the thing. And also, one thing that we cannot watch right now, that the orbital refilling, because they have moved the old starships had to be filled from the bottom up. That was the idea from the beginning, to be able to fill the booster, and then the booster would fill the starship on top of it, and then into orbit. 2 boosters would be back to back, butt to butt, they say, to transfer fuel. But no, the idea was that the refilling process would not be very much use, because most missions would be to low Earth orbit without the need for refueling. So this is an unnecessary complication, and they wanted to use a regular side filling. So they are the fuel lines are now running on the side, and the Starship will be filled by the quick disconnect arm. And maybe when they get to the orbital refueling, they will park the two starships side by side and try to. It's not very clear how they will do it, but they will try to transfer fuel that way instead of butt to butt. So that's it for the tour. I hope you liked this. There was a lot of information. I will probably do a shorter version to a regular video to sum up the most important parts. If you have questions, don't hesitate to ask. Could be now, or if you're watching it on replay, you can ask your questions in the comments. I will try to answer it too. So about the launch date, nobody knows, not even Elon Musk. There are a few things that need to be done before the launch. Of course, they need to finish the booster. Booster is almost finished. Maybe on the Raptors part, some work has to be done, and the Starship has to be finished first. They need to add a lot of thermal protection tiles. They have to change a lot of them too, because they are broken. There's the issue of the seal in the flaps, because that's a moving part. They have to make a seal, a steel seal to protect the hinge that's behind, and they do not. It's not working yet. So there are a few engineering problems they have to address before launching. But maybe the most problematic thing will be of another level. They have to wait for the FAA approval for the launch profile. They submitted their launch profile a while back now, and the FAA still has to come up with an answer, what they think of it, what they think of the problems, and then people are most likely other administrations will come up with their problems regarding the launch profile, and SpaceX will have to address every single one of those issues before being allowed to launch. And I think that could take a while, because the FAA still hasn't done published anyway any work on that matter. And the goal of launching in August seems completely impossible, if you ask me. Just for that alone, SpaceX could go very fast, but the FAA probably not so much. And I said before, maybe in the second part of September they could launch, but that would still be fast pace. Maybe in October or November would be a more realistic timeline. So be prepared to watch Elon Musk rant about the FAA and the administrative part of launching rockets, of testing rockets. And on some issues, he's right. There are simplifications to be made. SpaceX should be able to innovate, to test its hardware, but there are also concerns about the safety of the people around it, and the Starship will reach such an altitude and velocity that it could reach other countries, and therefore this is a matter of international safety, and these things have to be taken seriously. So maybe they should hurry up a little bit, but they have to do their work, and they probably are understaffed, as many state agencies are in the world, not only in the US. But let's wait and see. I hope it's faster than my predictions, but I don't see it coming. Don't hesitate to tell me if I'm wrong. Maybe in the future, in 3 to 4 months, if you can come back and roast me if the Starship launches in 2 weeks. But that's not very likely. But anyway, on Monday, so just after the weekend, they will bring the booster back to the launch pad. Probably not without the Starship, but only the booster to if there are not too much wind to do some testing again. They have to test that everything fits, all the whole dump pumps, all the fuel lines, the electricity lines, the command lines, everything has to fit. So they will try again on Monday. So until then, we'll call this live, this thing, call it a day. And if you don't have any question right now, I will end the stream in a few moments. Just I just started a little shop with some t-shirts. If you want, the link is in the description. If you want, I will try to find it because I just forgot where the link was. But as of today, there's only one design, and it will improve in the future. It's on Bonfire. Don't hesitate to look, and maybe you could suggest a design, suggest something if you want. I'll put it in the chat if you want. It's just for the moment, it's just a quote by Elon Musk, but I hope to improve it in the future. So have a nice evening, night, morning, depending on where you are and when it is. And good night.